Do you know what a parent graph is? Explain what a parent graph is.
The graph.
A parent graph is the original graph of an equation before it has been, what are those changes called? Transformed. The transformer, that's what these are called, transformer. You know, some from the movie. Then transform. If you used a word like that, I would know that you knew what these things are talking about. So y equals a times square root of x minus h plus k in this particular problem, because that's a square root. That's the first thing you got to be able to do. You got to be able to identify them all. Now let me call time out here and let's go to the next page. What are the ones that I've asked you to identify? I've asked you to identify this, which is what? Linear equation. So y equals x. There's no ax plus or a times x minus h squared with the linear equation. With the linear equation, it's y equals mx plus b. Okay, what's another one? A square.
Parabola.
So that's a parabola. So y equals x squared is that equation. If you want to move it around, you do the same thing. Change a, it flips it around the x-axis. X minus h squared plus k. H and k moves it right and left. H is opposite. K is opposite. A tells me whether it opens up or whether it opens down. Okay, there's another one. Here's this one, the square root. Okay. So you can identify a linear equation, a quadratic equation, a square root, a cube, y equals x cubed. What else do we have here? A v. What's a hard v? It's going to be asked all over the final exams that you know what a v is. What causes a v?
Absolute value.
That's right. Y equals the absolute value of x. Same thing. Y equals a times x minus h plus k. If a were negative, instead of a v that opens up, it's going to look like a housetop. If h is positive, it moves it to the left. If h is negative, it moves it right. And so, what else do we have? We got a rational expression. A rational expression looks like this. Those two curves right there. Okay. The reason those two curves are so easy to pick out is y equals 1 over x. If x were negative 1, y is negative 1. If x were positive 1, y is positive 1. So you end up with those two curves right there that are right there around the origin. So then the only thing is left is exponential growth and exponential decay. Y equals 1/2 to the x, and y equals 2 to the x. As for every one of these that you were to mention, I would know that you knew that much about parent graphs. So even though none of these right here, with the exception of the square root one, are listed on there, you would let me know you knew about parent graphs by mentioning these. So put a C diagrams below for other parent graphs. And down below you put other parent graphs. And so even though that question wasn't asked, you answer that in there. So I have a little bit more knowledge that you know where you're coming from. Okay? So to graph, y equals the square root of x. Make a t-chart. Okay? Write that. Make a t-chart. When you make a t-chart, what are these members right here? These are members of the x values. Pick your domain from real numbers with, what are those? Whole square roots. So I didn't pick any negatives here. I started right at 0, and then I went to 1, and then I went to 4. I went to 9, I went to 16. Gap. Come down at the bottom and explain the gap. Why is there a gap? What's the square root of 2? I don't know. What's the square root of 3? I don't know. What's the square root of 4? See, that's why I picked those numbers. So I picked those numbers and then graphed them, and they ended up looking like this. When I graph the points, it's the square root. Then over on the back, when it says give the domain of the function, give the range of the function, for what intervals is it increasing? Well, it's always increasing, or it's always decreasing. In graph B, the equation y equals the square root of x has been flipped. What else has it been done? It's moved, what is that, left 3, and then what is it, up 2. How do you move it left 3? How do you flip it?
Change it to negative.
Very good. Change that to a negative. How do you move it left 3? Right. Absolute value of x plus 3. Very important. H is opposite. Now, what I might do on y'all's is I would ask you to actually graph them. Instead of giving you the graphs, I would say the equation, and then you'd have to explain to me why you graphed it that way. Why did you move that thing left 3? Because that was a plus 3. Why did that thing get flipped? Because A must have been a negative 1. Why did I move it up 2? Because the constant, if you used a word like constant, it's on that vocabulary test. If you use the word constant, I would know that you knew that regardless of what number's sitting out there, I'm sorry, I said absolute value. This should be square root 2. We're working a square root problem here. So y equals negative the square root of x plus 3 plus 2. Then again, don't forget opposite of number underneath. Or inside the parentheses. Or inside the absolute value signs. Or in the denominator of a fraction. And so if you were to do something like this, I would understand that you would know that regardless of the equation, that's still that way. Right, those 5 topics that we had on our, you had a sheet that listed out all those 5 topics. It says linear equations, and then graphing lines, like various, you know what I'm talking about? And that's what I asked you to put on your blog record. What I suggested to you over the weekend is pick 2 of those. I'm going to pick the questions and make sure there's at least one for every one of those topics. Okay, so you pick 2 of those topics and really research them. And here's what you should Google. Finding the zeros of an absolute value equation. And then just read it. Put it right there underneath that blog, underneath that bullet on your blog. And so you've got just 2 of them that you spend about 15, 20 minutes on just looking up stuff, making sure you're comfortable with everything that you need to know about.
Yeah.
That's everything that's written right there. That's everything that's written there. Let me have you do a second question to Congress so I can try to use this tonight to post these out. I wanted to read on everybody's blog. Some of us are afraid of that blog. Just type yourself up. Just type it on information up.
Lost creative first activities.
Yeah, 2. Yeah, just pick 2. (33 and 34) are 2 problems that you're asked to factor in. The leading coefficient of these problems, the phrase the leading coefficient means the coefficient of the first term. Okay, what it is in this problem that lets you know how you do these problems is because it has a leading coefficient of 1. So 33 and 34 are both examples of problems that have leading coefficients of 1. And when that's the case, the way you know how to solve these problems is by looking at the C term, the third term, the constant sitting out there by itself, and asking yourself, what are the factors of the last term that I add together to give you the middle term? I saw this online last night as I was watching some videos and trying to figure out how I could help you guys out some. Some people will list those out. They'll list the actual factors of 5 out, almost like an ordered paper, if you will. They'll say one of the factors of 5 is 5 and 1. Another factor, well, it turns out that's the only thing that you have a choice for in factors of 5 that have given you 6. So in this problem, you take this C sitting out there by itself because the leading coefficient is 1. You ask yourself, what are the factors of 5 that have given you 6? So it's x plus 1 times x plus 5. Next video, I'll put an equals 0 out here on the end, and then we'll have to understand that if it's equal to 0, we have to solve it on down and say x equals the opposite of each of these things. But that's not the case here. We simply have a leading coefficient of 1 and the factors of 63. So if I want to take the factors of 63 and write them out, we're going to start at 1 and 63, 3 and 21. Eventually I'll get to 9 and 7. That's the factors that I'm looking for, because 9 times 7 is 63. And negative 9 plus a negative 7 is negative 16. So my factors of 63 that add together and give me 16 are x minus 9 and x minus 7. Once again, that's my final answer, because x times x is x squared, negative 7x and negative 7x. Those 2 terms add together to give me negative 16x. And if you remember just a second ago, that's what I said, what the factors are of 9 times 7, the factors of 63, whose sum is negative 16. And then again, I stop right here because it's not equal to 0. If I look on ahead, just take a quick sneak ahead at numbers 37 through 39. I notice that those are all set up equal to 0. Or if they're not set up equal to 0, that's the first thing you have to do to them. You have a quiz star, there's one of your quiz stars that's solving for x. That's a linear equation. You just get your numbers on one side, variables on the other. Then there's another one that's solve for x by factoring. When you have to solve for x by factoring, after you get your factors, after you've got what you think the answers are, let's say, and answers here are a plus b and c plus d, you set each of those factors, whatever they are, right? A plus b equals 0, c plus d equals 0, and then solve each of those equations for whatever variable you have in the problem, like x or
X squared you're solving for X, or Y squared you're solving for Y. In this case, I don't have a variable there, so maybe I need to solve this for A. So A would be equal to negative B,
And C would be equal to negative D. It's called solving that equation. The reason I need to solve it is because it has equal 0 in it. 33 and 34 don't. So you simply got to stop when you have the problem factored out. Which also leads to the way that you can check these is by multiplying out and make sure it gives you what we started with.